So, welcome back to this quantitative finance NPTEL MOOC online course. So, hope everybody is fine and enjoying the course. So, we have covered a lot starting from portfolio management to different concepts of how portfolios are made. Then we went into derivatives. We did discuss about different type of averaging techniques. So, there is a whole gamut of things we have covered. There are a whole lot of things to be covered. So, and I am sure that this course is interesting to all 1200 plus students who have registered. I wanted to say a few things because as the course was continuing, I do understand the coverages are happening a little bit fast. But on the other hand, I would definitely mention that once you get the interest, you can pick up all the information from the net, which is really very helpful to give you a good understanding about the concepts which we are discussing. And also you are most welcome to send your comments, you are most welcome to send your queries, and I am sure that with a little delay, maybe a delay of one and a half days maximum, I am definitely going to answer all the queries which are there. So, continuing that we are in the area of par yield, then we want to find out what is the actual coupon rate of the bond, how the zero rates are there, how you find out the forward rate, so on and so forth. So, with the discussion we were having in the last class was there are 5 different bonds. In the first 3 the coupon payments are 0, for the fourth one the coupon payments is 8 units, dollars, rupees, whatever it is, being paid semi-annually. For the second one it's $12 paid semi-annually, and the interest rates were given as the price of the bond were also given based on their actual demand and supply, and the face values are also given on the first column. So, for the first bond, for a face value of 100 you are getting 97.5, which is 2.5, which can be earned out of an investment of 97.5 in 3 months, because if you remember it was for 3 months duration. So, what we will say exactly is that the 3-month rate for this one, and then we convert into a yearly one, it will be 4 times of that. So, it will be 4 times 2.5 divided by 97.5. So, 4 why? It is being compounded 4 times. Why 2.5? This is the overall amount which you are receiving. What is 97.5 is the overall investment which you are making. So, this comes out to be 10.256, which is per annum quarterly compounded. So, again if you use the same formula which we have been discussing, continuous compounded, the continuous compounding rate would come out to be 10.127. So, this we will use later on in our calculation. So, if you remember, so this is important, which will be utilized by us in our future calculations. Now, consider the second row. So, here again the face value was 100, the actual value of the bond depending on demand and supply is 94.9. So, this comes out to be 5.1. So, now you will ask the question, this 5.1 which you are getting after how many months? It is basically 6 months, which is half a year. So, you will find out the 6 month which is semi-annually compounding percentage per annum would come out to be 2 multiplied by 5.1. 5.1 is the total value which you are getting, the difference, and the investment is 94.9. So, that comes out to be 10.748 with semi-annual compounding. Now, again if we convert into a continuous compounding rate, we use the same fundamental principle, and that comes out to be 10.469 per annum continuous compounding. So, this is the value which is important for us. Now, consider the third row. So, an amount face value 100, total amount which you are getting after demand and supply taken into consideration is 90, which is 10. So, 10 is the total amount in units of rupees or dollars, whatever it is, which is being obtained after 12 months. So, your compounding is being done once in 1 year. So, hence the percentage is calculated, comes out to be 11.11 with annual compounding, and it is basically per annum. So, if you find out, so what you are doing is exactly this, to find out 11.11, which you are the same fundamental principle you are doing for the other calculation also. This is the total amount which you are getting, investment is this, how many number of times compounding is 1, so you will multiply it by 1. So, in other cases it will basically be multiplied by the number of compounding you are doing, multiplied by the total amount you are receiving, and in divided by the overall demand and supply value of the bond which you have. So, again if you convert it into a continuous compounding case, it comes out to be 10.536 per annum continuously compounded. So, we have found out all the values of continuous compounding case for the case when it was being done on a quarterly basis, for the case when it is being done on a semi-annual basis, and for the last case which is this which you are seeing on the slide is 10.536 is for the annual basis. So, now what we need to do is that now you need to go to the next step. So, if you remember we were given for quarterly case which you have already found out, for the monthly case, for the semi-annually case we have found out, and the last one is being for the yearly case we have found out. So, with these three sets of information we want to proceed one step forward and find out what is for the 1.5 years. Then once we find out the 1.5 years, we want to proceed one step further and try to find out what is the 2 years interest rate depending on the calculation which we have already done. So, if you remember the fourth row was there, it was being paid a coupon of $8 and it was being paid semi-annually. So, the total value of money which you are getting after 6 months is 8/2. Then the second coupon you will be getting is again 8/2 which is being paid after 1 year. The third one would be basically paid along with the principal amount which is 100. So, you will get a value of 100 plus 8/2 and that will be paid after 1.5 years. So, once you equate the left hand side all the three values which I mentioned, that is 8/2 after 6 months, 8/2 after 1 year and 100 plus 8/2 after 1.5 years. So, if you equate including the interest rate which you have already found, the overall demand and supply value at which the bond is being traded is 96. So, now let us go through the calculations slowly. So, this is the coupon which you are getting after 6 months. So, now the interest rate which you based on which you will find out the present value is the one which you found out for the case of half a year. So, that is basically 10.469. So, obviously it will be minus because you are trying to find out the present value, and multiplied by time, time is basically 6/12 which is half a year. For the second case which is being paid after 1 year, again the coupon value is 8/2 and the time frame is now 12/12 which is 1. But if you check the interest rate, that is 10.536 which is continuous compounded per annum interest rate for 1 year. So, this is minus being because you are trying to find out the present value, minus of 0.10536. And for the last calculation which you will need to do on the left hand side, so this is the left hand side which you are doing, it is 100 is the face value, 8/2 is the coupon payment. Now, you will ask yourself what is the interest rate? You do not have that interest rate for 1.5 years. That means, if you invest at time t is equal to 0, you want to get back the total amount of money, whether it is coupon, whether it is principal amount, as immaterial, you want to get the money after 1.5 years. So, in between there are no payments which are being done to you, or neither are you depositing any money in the whole transaction. So, considering the interest rate which is continuously compounding per annum interest rate, and the total time duration is 1.5 years. If you need to find out, you equate it to 96 which is the demand and supply value. So, if you find out that R value comes out to be 10.681 which is the continuous compounding interest rate for the time duration. Now, having said that, what you have done is that you are going step by step. So, you have already found out, again I am repeating, for the first quarter, then for the half year, then for the 1 year, then for 1.5 years. And the last row is basically for the 2 years. So, what you will do? You will first find out what is the coupon. Coupon is basically 12. Now, you will ask the question, how many times is being paid in a year? It is being paid once after 6 months. Then the next one is after 1 year. The next one would be again after 1.5 years, and it will continue in this sense. So, if you see the total duration is 2 years. So, how many such payments would be there within that 2 year time frame? So, first would be after 6 months, which is 12/2, and the time frame which you are trying to find out is t is basically 6/12. I will come to the interest rate later on. The next one is again being paid 12/2 the total amount, and it is being paid after 1 year which is 12/2. The next one again the coupon of 12/2 would be paid after 1.5 years which is 3/2. And the last one which will be paid after 2 years, it is written. So, but in the last year, remember there are two payments being paid. One is the coupon one 12/2 and one is the face value. So, the next question will be what are the interest rate? So, we already know 10.469 is the continuous compounding interest rate for half a year. So, from the actual calculation, so you will utilize it here. Next question is that what is for the 1 year? We already know it is 10.536 continuously compounded per annum. So, you will use it here. The next question is that what is for the 1.5 years. So, we have already just calculated that comes out to be 10.681, we use it here. That means, we are proceeding one step at a time. So, the last information which we just got is 10.681, we utilize that. And utilizing this whole value, R is unknown for the 2-year period. That means, you are investing at 0 time, getting back all the amount of money after 2 years without any payments being made in between or without any payments being made back to you in that 2-year period. So, that is interest rate which is continuously compounding being done per annum. So, that you equate, that is every value which you have done is basically on the left hand side. So, you equate that onto the right hand side. What is the value? That is basically the demand and supply value which is already noted on the last column in the table, which is 101.6. Utilizing that, you find out the interest rate at 10.808. So, what you have done is that using this concept of going one step at a time is basically like the bootstrapping. When you have a very high gumboots and when you tie up the laces, you basically start from the bottommost level and then basically tighten up as you go up to the knee. So, it's exactly the same thing. In the bootstrapping, you go one step at a time. So, first you found out for the half year, which is 10.469. Based on the calculation, you proceed to the next step. Then you find out the 1 year, which is 10.536. Then in the last slide, we found out basically the 1.5 year, which is 10.681. And in this slide, we basically find out the interest rate for 2 years, continuous compounded, which is 10.808. So, if you had basically 2.5 years, 3 years, we could have basically calculated the interest rate based on the same principle. Now, remember one thing before I proceed further on to basically have a sense of what you mean by the forward rate. Zero rates are very important to understand, means that these zero rates means zero is not the interest rate or something to do with interest rate, is basically the coupon payment or in between payment which is being made to you or the deposits which you are making within that time frame, it is 0. That means, there is no transaction. Hence, they are considered as the 0 interest rate based on which you do the calculation. So, the value of 10.469, the value of 10.536, the value of 10.681 and the value of 10.808 are the 0 rate continuous compounding for the case half year, 6 months, next for 1 year, next for 1.5 years and the last one is for the 2 years period. So, now once you note down, you in the first column you have the maturity in years which is given, which is 1/4 of a year, half a year, 1 year, 1.5 years, 2 years and the interest rate which you have already found out are noted down in the next column, which is the second column. But note down again, I am again repeating, these are the 0 rates and they are being continuously compounded and the values are being found out on a annual basis or a yearly basis, that is percentage per annum. So, if you draw the curve for the maturity which is basically plotted on the x axis and the 0 rate which is plotted on the y axis, this value gives you that in between, if you want to find out any 0 rate between was 0 month to say for example 1/4 of a year, then obviously you will take the interest rate as it is, which is given as 10.127. If you want to find out the any interest rate between say for example 1.25 to 1.5, so obviously you will find out what is the slope. Based on the slope you will find out. So, it will basically be given by the values which are there. So, you have to basically plot them and find it out. So, that will be just simple interpolation. So, you have already these values. So, you will interpolate and find out what is the 0 rate. Not that they will give you the exact calculation, but they will give you a good approximation of whatever the existing value of the 0 rate is. Now, having discussed about the 0 rate, the coupon rate and all these things, now our next question is that how do you find out the forward rate? But before you answer the question that how we calculate the forward rate, our main concern or question would be what is a forward rate? So, forward rate is the interest rate implied by the current 0 rate for a specified future period of time. So, let me explain with the slides which you already discussed. So, we had the 0 rate for 1/4 of a year, for a half a year, for 1 year, for 1.5 years and 2 years. Now, what if I ask you the question that what is the interest rate which is being paid in between the time from 1 to 1.5 years? That means, we already know the 0 rate from 0 to 1 year. we already know the interest rate from 0 to 1.5 years. So, what we are interested to know is that what is the interest rate between 1 to 1.5 years, or in the similar way we know the interest rate for 6 months, we know the interest rate for 1 year. This interest rate means from 0 to 6 months and 0 to 1 year. So, what we are now interested to find out is that what is the interest rate which is applicable for the time frame from 6 months to 1 year. So, these interest rate in between depending on the 0 rates which you have already found out are known as the forward rate. That means, once you have reached the 0 rate, if you want to go one step forward, what is the forward rate based on which you can do the calculation. So, obviously, the concept would be the same as we have utilized for the continuous compounding concept and the compounding concept m number of times. So, the concept would be same, that we will try to basically equate two equations, one on the left hand side, one on the right hand side, and based on that we will try to find out what is the interest rate, such that given the 0 rates we can find out the forward rates, or given the forward rates we can find out the 0 rates. So, let us see how we can do that. So, consider another example. So, all of these examples are taken from John Searle. So, you need not be too much bothered. Once you understand and then you read John Searle book, it will definitely give you a lot of information how the calculations are being done. So, in the first column you consider the year. So, they are given in units of years. It could have been 1.5 years also, 2 years also, 2.25 years also, that is immaterial. So, once you decide on the time frame it is years, stick to that and do your calculations accordingly. In the next column you have basically the 0 rate for n number of years of investment, which means that if you see the first value which is 10, it means for a time frame from 0 to 1, the interest rate for no amount of transaction taking place between you and the bank where you have deposited the money. That is a hypothetical case we are considering, that no amount of money is being transacted between you and the bank, that neither are you depositing nor are you taking out. Then the interest rate or the 0 rate for the time duration is 10% per annum continuously compounded. If I see the value of, say for example 11, it means that if I invest in at time t is equal to 0 and stick to that investment without any exchange of money taking place from the 0th time to the 4th year, then the interest rate based on which you can find out the calculations and do all the calculations is the 0th rate, and which is known as the value is 11.0, which is per annum continuously compounded. Now, having said that, we want to find out what are the interest rate in between. So, if you look at the third column with the last column, which is basically the forward rate for the nth year, and again it is basically being given per annum continuously compounded. So, what does this 11 mean? This 11 means basically what is the interest rate which is applicable for a time duration from 1 to 2, or say for example, if you find out 11.5, we want to find out that what is that value, or what is that value of 11.5 and where it is applicable. Is it basically applicable from the 4th year to the 5th year, or is it applicable from the 3rd year to the 5th year? We will see that how the calculations can be done. So, once you do the calculation, you can immediately understand the 0 rate which are given in the last column would now make sense, as that based on the forward rate, sorry, for the forward rates which you have found out in the last column would give you any information that given the 0 rates, how you can find out the forward rates, or given the forward rates, how you can basically go back and calculate the 0 rate. Now, suppose that the 0 rate for maturities for T1 and T2 time period and R1 and R2 are the interest rate which are given, with both rates being continuously compounded and they are being given on a per annum basis. Then the forward rate for the time period in between T1 and T2 would be given by this formula. So, the concept is very simple. What you do is that consider the A is the amount of the principal amount, and consider there are two time frames. So, one time frames are given by T1 is this time frame, and consider T2 is this time frame. So, obviously, this time difference would be T2 minus T1. So, what we are given is the 0th interest rate for time period T1 and 0 interest rate for time period basically T2. So, what you have is that A e to the power R2 T2, which is the total amount of money which is being done investment for this time period, should be equal to this amount, which is now A e to the power R1 T1. Then again this is being invested for this time duration. So, this now the time duration is T2 minus T1. So, obviously, you will have E, and this R is the forward rate which is happening between the time frame of ending of T1 and basically ending of T2. So, this is the time duration which you want to find out. So, this interest rate, if it is R, so it will be given by T2 minus T1. So, AA will cancel. So, it is basically all R or to the power of E. So, you can best equate them and try to find out what is the relation which is given here. Similarly, if you have T1, T2 and you have the R bar value, so you have R2 value and R value, you know the time T2 and the T2 minus T1. Similarly, given that, you can find out the relationship and find out what is R1. So remember here R1 and R2, again I am repeating, are the 0 rate for time duration of T1 and T2, and R is the forward rate for the time duration from between T1 and T2, that means the time difference in between which is happening. So all your datum for the 0 rate is basically 0, and for the datum for the forward rate is basically, for this example, is given as T1. Now if you draw the slope for the different rate curves, so the rate curves are forward rate, if F is FR, ZR is the 0 rate, P is the par yield. So if you basically have a yield curve which is sloping upwards, then the values of the forward rate, the 0 rate and the par yield would basically look like this, where the forward rate would be the red one which is on the topmost, then you have the 0 rate and the par yield. And if you have a yield curve which is downward sloping, so obviously that these values will just be the reverse, mirror image. But when it happens the mirror image, it basically makes sense to say that the forward rate would be the downmost sloping, then you have the 0 rate and then you have the par yield. So depending on how the values are changing, whether the yield rate is upward moving or downward moving, you will basically have these values. Because remember, they are being calculated using the same concept which you have just discussed in the last class and today's class. So once you understand the calculations, you can definitely say, depending on whether the yield curve is upward moving or downward moving, the positions of the par yield, 0 rate and the forward rate would be exactly as is it given in these two slides. And again, remember, we are trying to basically measure the maturity on the x-axis and the rates on the y-axis. Now the instantaneous forward rate. So if you consider that the 0 rate is from 0 to t and another 0 rate is from 0 to t plus delta, so obviously the delta time period interest rate which you have is basically known as the instantaneous forward rate. So how do you find out? So the instantaneous forward rate for a maturity t is the forward rate that applies for a very short period of time, for a time period starting t and ending at t plus delta t. So if you find out the 0 rate for t and you find out the 0 rate, say for example for t plus delta, you can easily find out what is the actual forward rate for that delta at t time, unit of time. So remember, this R is basically the TR interest rate, 0 rate, and the value which you find out is basically will give you the value of the 0 forward rate. So if you remember, if I go back to the previous two slides before, so this formula, when you consider the time difference T2 minus T1 is basically slowly going to delta, where delta basically goes to 0, you can find out what is the rate of change of that function, such that you can find out the instantaneous forward rate. Now what is a forward rate agreement? A forward rate agreement is a forward rate contract where the parties agree that a certain interest rate will apply for a certain principal during a specified future time period. So all the calculations which you have done for the par yield, for the coupon bond, for the 0 rate, for the forward rate, all these things can be utilized in order to calculate and find out what is the forward rate agreement based on which two parties can go and sign a contract based on a forward. Now having said that, when all the calculation which you have done for the forward, remember that the difference or the conceptual difference between the forward and futures for our discussion is not much. So once you are able to find out the forward prices and the forward rates, similarly you can find out the interest rate based on which you can do the calculations for the futures markets also. Now the theories of term structure. So before we proceed, I will like to discuss very few comments and in very simple details. So we will just mention the highlighted points, and in the next class we will discuss what are the actual implications of this. The things we will discuss in the next class are what is the expectation theory, what is the market segmentation theory, and what is the liquidity preference theory. So having said that, I will urge the students again to read John Searle and understand what are the different type of interest rate based on which we will do all the calculations, and we will try to see how the interest rate derivatives are also derived based on this fact. Thank you very much. We will start off the discussion of the term structure in the next class. Thank you.